Hello everyone, welcome to my channel Civil Construction Topics. Today I am proceeding with an illustrative example from IS 10262 for proportioning of concrete. Understanding this topic is complicated for the persons who are new to this topic, but I will try to make it interesting and easy to understand. The ultimate aim of this explanation is to make everyone to understand the topic and design the concrete with the lowest cement content by satisfying all codal provisions. Low cement content leads to reduced carbon footprint. When you design the concrete with the lowest possible cement content, which will reduce the carbon footprint, that is carbon footprint in the environment that is produced due to the production of concrete. I request everyone to watch the video till end for better understanding. Here you can see illustrated example of concrete mix proportioning which is given in Annex A of IS 10262. To do any concrete proportioning, initially we need to get basic data regarding the requirements of concrete design. Here you can see A1 stipulation for proportioning, grade of the concrete, grade designation, that is the grade of the concrete. The grade requirement is M40 and the type of cement. Here we are using PPC cement. PPC cement conforming to IS 1489. And the maximum nominal size of the aggregate. So there are different sizes of the aggregate, 20 mm, 10 mm, 40 mm. Anyway, we decide the size of the aggregate based on the requirement of the site. That is the congestion in the reinforcement. If the spacing in between the reinforcement is more, we can proceed with 20 mm or 40 mm aggregate. And the reinforcement is very congested. In that case, we will proceed with 10 mm aggregate. Anyway, for most of the RCC works, the maximum size of the aggregate used is 20 mm. Minimum cement content and maximum water cement ratio to be adopted. You should decide the minimum cement content and maximum water cement ratio, which is given in table 3 and table 5 of IS 456. Now I give you a clear idea by opening table 3 and table 5 of IS 456. You can see here the table 3 of IS 456. There are different types of exposure conditions: mild, moderate, severe and very severe and extreme. In the current proportioning in our current illustrative example, the condition is severe. The severe condition, you can see the description of the severe condition: concrete surface exposed to severe rain, alternate wetting and drying or occasional freezing, wet or severe condensation. Concrete completely immersed in seawater, concrete exposed to coastal erosion. When the structure is fulfilling this condition, then we consider it as a severe condition, and you can go through the remaining conditions also, that is mild, moderate, very severe and extreme. And we'll go to table 5. In table 5 they have given the minimum cement content and maximum water cement ratio and the minimum grade to be used for the type of exposure condition. You can see that this is plain concrete, that is PCC, and this is reinforcement concrete. Currently our design is for reinforcement concrete and our condition is severe. So you should use the minimum cement content of 320 and maximum water cement ratio of 0.45 and minimum grade of concrete is M30. And currently we are designing is M40 grade based on the structural requirements, and the minimum grade for severe condition is M30. So you can see our grade is greater than M30, that is M40, which is fulfilling the requirement of severe cement content. Next condition is workability requirement. Here the adopted workability is 75 mm, that is slump. The workability is decided based on the type of pouring. If you are going to pour concrete with pump, generally the slump requirement will be more, and you should consider the type of structure. Depend on the structure also, you will decide the slump requirement. Here the slump requirement is 75 and method of placing, whether you are pouring the concrete manually or by pump. Here we are pouring the concrete manually. And degree of site control. Degree of site control is the quality control that is available at site. Here the degree of control is good. and the type of the aggregate. There are different type of aggregate, that is natural aggregate and crushed aggregate. Here we are using crushed angular aggregate, that is produced from the crusher by crushing the bigger rock. And then maximum cement content not including fly ash. In any concrete mix design, the maximum cement content should not exceed 450 kg per cubic meter, which doesn't include fly ash. If you are using fly ash or any other mineral admixture, the cementitious content should exceed greater than 450 kg per cubic meter. And the chemical admixture, here we are using chemical admixture to reduce the water content. There are different types of chemical admixtures, super plasticizers. Anyway, here using super plasticizers. Okay, and then test data for material. After deciding all the basic details of concrete design, we will proceed for testing of raw materials, and finally we got the test data of the raw materials. We can see the cement uses PPC, and the specific gravity of the cement is 2.88. If you are using OPC, the specific gravity will be around 3.14, which will get after conducting required tests. And the chemical admixture, I have explained earlier, we are using super plasticizer and specific gravity. You need to do testing for specific gravity of the coarse aggregate, fine aggregate, admixture, or whatever the mineral admixture, anything you are using. Here the specific gravity of coarse aggregate 2.74 and the specific gravity of fine aggregate 2.65. Chemical admixture is 1.145. And next we need to do the water absorption test of the aggregate. That is, for coarse aggregate we got 0.5% as water absorption, and fine aggregate 1% as water absorption. And next we need to check the moisture content in the aggregate that we are going to use in our concrete design. The moisture content can be checked from with reference to IS 2386 part 3. You can go through this code for detailed idea about moisture content. Coarse aggregate, here you know that in rainy season the aggregate will absorb some moisture. In that case we will check the moisture content of aggregate. Anyway, here our moisture content is nil for both coarse and fine aggregate. And we need to check the sieve analysis of the aggregate. We need to check the sieve analysis for both coarse aggregate and fine aggregate. The combined grading of 20 mm and 10 mm aggregate should satisfy the requirement as given in table 7 of IS 383. You can see the individual gradation of 20 mm and 10 mm. These are the sieves we are going to check the gradation. For 20 mm, 10 mm 4.75. This is the individual gradation for 20 mm aggregate, and this is the individual gradation for 10 mm aggregate. Anyway, we are going to blend 60% 20 mm aggregate and 40 mm 10 mm aggregate to achieve the required gradation as given table 7 of IS 383. Now I will show the table 7 of IS 383. Let's go through table 7 of IS 383. Here our nominal maximum size of the aggregate is 20 mm. So you can check this 20 mm. For nominal max 20 mm aggregate, this is the blending requirement. Please make it clear. For 20 mm from 20 mm sieve, 90 to 100 mm should pass. From 10 mm sieve, 25 to 50 mm 5% should pass, and 4.75 mm 0 to 100 0 to 10% will pass. You can see in our case this is the combined gradation which is satisfying the requirement as given in table 7 of IS 383. And for fine aggregate there are different zones which is given in table 9 of IS 383. Please go through this IS 383 table 9. There are different zones of fine aggregate: grading zone 1, grading zone 2, grading zone 3, grading zone 3. These are the sieve designation, and this is the percentage passing which is given here. And in our design, our fine aggregate is fulfilling the requirements as given in grading zone 2. So here they have specified conforming to grading zone 2. We are using grading zone 2 of table 7 of IS 383. Next, you should decide the target strength of the concrete. F dash ck equal to fck plus 1.65 into s. In our earlier video, I have given detailed explanation regarding fck and f dash ck. Anyway, I am giving once again. Fck is the characteristic compressive strength. Here we are designing concrete for M40 grade. So the characteristic strength is M40 and S is the standard deviation. You can see here F dash ck, target average compressive strength at 28 days, FCK, characteristic compressive strength at 28 days, and a standard deviation and factor based on the grade of the concrete. For deciding target mean strength, you should use any of the formula as given here. So you should get the standard deviation, assumed standard deviation from IS 10262, which is given in table 2. Now I will show you the table 2. From table 2 of IS 10262, assumed standard deviation is given. Here we are using M40 grade of the concrete, so our assumed standard deviation is 5. We can use this for finding out the target mean strength. Okay. Here you see we have used standard deviation as 5 and we have got a target mean strength of 48.25, that is 40 plus 1.65 into 5. So now you should design the concrete to achieve the average target strength of 48.25 Newton per mm square for M40 grade of concrete. And next we will proceed with the approximate air content. For any concrete design, depend on the size of the aggregate, that is certain percent of air is available in the concrete, which is defined in this IS 10262. For 20 mm aggregate, the assumed air content is 1%. So we are proportioning the concrete for 99%, whereas 1% is considered as air. This is for non-entrained concrete. If you are doing any entrainment in the concrete, the air content will be based on your entrainment percentage. Next, selection of water cement ratio. You should decide the water cement ratio based on the required target mean strength. Here our target mean strength is 48.25. So the water cement ratio is decided based on the type of cement we are using and the workability requirement. Anyway, as discussed earlier from table 5 of IS 456, the maximum preferred water cement ratio for severe condition is 0.45. The water cement ratio that we are going to use should be less than 0.45. Anyway, from figure 1 of 10262, we have a graph. From the graph, we can decide the required water cement ratio. Now I will show the figure 1 and accordingly we'll find out the required water cement ratio. Here you can see the figure 1. That is, there are 3 curves in this graph. Curve 1 for cement, compressive strength of cement in between 33 and 43. And curve 2 is for compressive strength 43 and 53. For expected 28 days compressive 53 grade. Here we are using cement of PPC. You can see while using PPC, the appropriate curve as per the actual strength may be utilized. In the absence of 28 days compressive, curve 2 may be utilized. We had checked the compressive strength of the cement earlier. We can proceed as per this criteria. If you don't know the compressive strength of PPC, here in the note they have decided you should proceed with the curve 2. So now I am proceeding with the curve 2. Our required compressive strength is 48. You can see here it will come in this range 48, and you can come like this and you will drop a line. When you touch this curve, you need to drop a line and you can check it is coming around 0.36. So you should use a water cement ratio of 0.36. Now we had finalized our water cement ratio as 0.36 from the figure 1 of IS 10262. Anyway, you can decide the water cement ratio based on your earlier experience also. It is non-mandatory to use figure 1. Based on your experience and the strength requirement, you can adopt any water cement ratio, but it should satisfy the requirement as per the table 5 of IS 456. Next, you should decide the water content. And the water content also should be decided based on the experience also, but anyway, as per this codal we'll discuss. They have given different water content based on the size of the aggregate. You can check table 4. In table 4 they have given water content based on the size of the aggregate. Now I will show you the table 4. Please check the table 4. Nominal maximum size of aggregate is here. Here our nominal maximum size is 20 mm and the water content is 186 kg per cubic meter of concrete, which is given. And I will suggest you go through the notes also. Water content corresponding to saturated surface dry of the aggregate. This water content does not include the absorption of the aggregate, whereas the water content should be increased for dry aggregates. The quantities of mixing water are for using computing cement, cementitious material content for trial batches. The water content described in table 4 is just for a slump of 50 mm for 20 mm aggregate. For every 25 mm increase of slump other than 50 mm, there is an increment of water by 3%. You can check here. Here our slump requirement is 75. So our slump is increasing 25 mm extra. So we need to increase water percent of 3%. So you can check here we are adding 3% of 186. So the total water content is 191. And here we are using superplasticizer. So water content may be reduced by using the superplasticizer. You can check that the reduction of water with your superplasticizer that we can get from the technical data sheet of the admixture or based on the trials you have conducted. So based on the trial data, the water content reduction of 23% is considered while using. Here the water content is decreased by 23% by addition of superplasticizer at the rate of 1%. So we can check our total water requirement is 191 and the reduction is 23%. So you can check 100 minus 23 is 77. So our final water requirement is 147.52. Anyway, I will make you a detailed calculation in Excel. Please go through, which will be very useful. You can see here 186. Just I am increasing my font size for your better clarity. I think it should be increased further more. $20 mm aggregate and for 50 mm slump, which is given in code. Now our slump requirement is 75 mm. Slump requirement is 75 mm. There is a increment of 25 mm slump. So for every increment of 25 mm slump, 3% of water will be increased. So %3 into 186. This is the increment of water. So our total water requirement will be this is our total water requirement 191.6, which is given here 191.58, which is given here, And one more thing is, by addition of admixture, the reduction in water is getting reduced by 23%. So the net water content will be 100 minus 23. The net water, so I am multiplying this 190 into 77%, that is 148. By addition of admixture, our water content is reduced from 191 to 147. I have given a brief detailed calculation. I think you people had understand. If anyone having any doubt, please drop in comment box. And now we are going to calculate the cement content. Everyone know that is water cement ratio. We have decided as per the figure 1. Our decided water cement ratio is 0.36. Cement content, so water cement ratio is 0.36. So therefore the cement content is 148 by this one. I will give brief explanation for this also. Water by cement, this is water cement ratio. Our water cement ratio is 0.36. If you need the cement content, just by mathematical calculation, water by 0.36 is equal to cement. Our water is 148 divided by water cement ratio is 0.36. So our cement content is around 411, which is shown here, and this is the 411.11. By round offing they are using 412. We can consider it as 411 also, there is no issue. And from table 5 of IS, minimum cement content for severe condition, which I have seen earlier, is 320, and our adopted for cement content is 412, which is satisfying the requirement, hence it is okay. I think everyone has understand about deciding the target mean strength, deciding the water cement ratio and water reduction based on the admixture you are using, and the water requirements based on the slump requirement, and finalizing the cement content and cross checking with the table 5 of IS 456 and table 3 of IS 456. Now I am proceeding with A10, proportioning of the volume of the coarse aggregate and fine aggregate. I suggest everyone to go through this before proportioning of the aggregate, and it is not compulsory to use this for proportioning of aggregate. Based on the experience, you can adopt the proportions of aggregate. Here for zone 2 they have given different type proportions of fine aggregate. You can see here the proportionate volume of coarse aggregate corresponding to 20 mm aggregate and fine aggregate for zone 2 water cement ratio of 0.52 is 6:2. I think in general you should proceed with the trials, and accordingly you should decide the proportion of aggregate, which will be very useful and which is practical. This is the mix calculation which I have shown. The total mix calculation I have given in my earlier video. Everyone please go through that video. I am sharing the link I am sharing my earlier video link in this description box.